reason we're here today is to re-examine the use of high friction surfacing because its popularity seems to be waning a little bit. Some authorities have stopped using it completely. And so today we want to sort of challenge some preconceptions about the product, particularly about its service life, and particularly about alternative types of treatments, for example, high PSV asphalt. Do they perform the same as high friction surfacing? So that's what we're talking about. There's different types of high friction systems in use, and the next speaker will go into those into some detail. It was developed primarily to improve or reduce wet skid related accidents. The market grew to about 4 million square metres. Today it's less than 1 million square metres, so it's decreased quite markedly. And I think the reduction really is tied in with the need for councils to reduce expenditure, reduce their maintenance budgets, and so on. So it's got caught up really with all that need to save on costs, and the perception is it doesn't last very long, it's expensive, it's a discretionary spend, and we don't need to use it anymore. And this is really why we use it. If you're into scrim and measuring skid resistance, the market high friction is 0.5 scrim or above. And achieving skid resistance under wet conditions is quite complicated. There's a lot of parameters that are affected. You can see some on the screen there. Surface texture and the aggregate type is absolutely critical to achieving good wet skid resistance. And there's two types of texture. There's micro texture on the aggregate, and there's macro texture, which is the texture there. The reason that anti-skid is unparalleled really is largely down to the aggregate type that's used, calcined bauxite. It doesn't polish. It's got a very high PSV, very high resistance to polishing under traffic. So it retains its micro texture, which is very critical for achieving wet skin resistance, particularly lower traffic speeds. Macro texture becomes more important as traffic speeds increase. We haven't got a presentation today on calcined bauxite, so I'll just say a few words about it. The aggregate comes from bauxite clay. It's quarried in places like China and Guyana and India. It's calcined in a kiln, very high temperatures, and it's an incredibly hard material, very high in alumina content. There's been some research done over the years on its use and its performance, and you can see on the screen there are two footprints which are meant to replicate the contact between the car tyre and the road surface. You'll notice that the footprint under the car tyre travelling over a high friction surfacing looks quite different to a HRA surface. The HFS surface provides lots of high pressure contact points, like needles really, that provide very high friction. And you'll also notice that there's low density on the high friction footprint, which creates lots of channels to improve the hydraulic conductivity and help to shed the water between the car tyre and the surface. We know high friction works. There's been lots of research done on its use over the years, lots of testimonials. We know it saves lives. And sometimes we need to just focus on the value it provides, not just the cost. Some work done by RSTA a number of years ago. They looked at different schemes, different ways of improving road safety. At the top there, anti-skid. They looked at 34 schemes. Average cost just over £8,000 a scheme. The interesting figure is in the third column there, 57% reduction in accidents as a consequence of treating those sites, and the full year rate of return 352%. And high friction surfacing is embedded in all of the specifications, in the spec for highway works, in the DMRB, the design manual for roads and bridges. And I'm sure it features, or should feature, in every local authority's asset management plan and skid risk policy. You're no doubt all aware of the new code of practice coming in October, well-managed highway infrastructure. So it's a mandatory requirement now for authorities to have a skid list policy, and we'll hear more about that later on this morning. The specification clause is clause 924. It doesn't say very much. It just says that the system to be used should have HAPAS or equivalent certification or product assessment. There's a code of practice published by RSTA jointly with ADEPT about a few years ago, about 5 years ago. It's been recently updated. The code of practice is important because it provides a basis for providing a 5-year guarantee. So we would encourage all authorities to think about stipulating a 5-year guarantee in contracts. HD 36 is important. That provides guidance on how to set your investigation levels and PSV requirements dependent on the site category. And HD 37 is part of the DMRB, which is being updated. There is a presentation later on today about HAPAS and the HAPAS scheme. I think the scheme for high friction servicing was in fact the very first HAPAS scheme. I think it sprang into life about 1995. Currently there's 21 certificates in issue, which cover a wide variety of different types of high friction systems. And the important thing also is that the scheme covers both the performance of the product, but also the application of the product. So applicators also need to receive HAPAS approval. The market's changing. The BBA dominated this particular product assessment certification scene for many, many years. We've now got a company called PTS who are providing a similar type of, or an equivalent type of product assessment certification. So when to use it, I think basically your skid risk policy will outline where you should be using high friction surfacing, anywhere where there's a scrim requirement of 0.5 or above, but typically approaches to roundabouts, crossings, junctions, where you've got a bad accident history on the site. I mentioned HD 36. This is table 3.1. HD 36 is now going to be called CD 236 in the new DMRB as part of their revision. And but the table remains pretty much the same. The shaded rows is the default value, investigator level driven value for PSV. And you can see there where high friction servicing features in the table, depends on the site category. So out of the 10 site categories in HD 36, only 5 currently require high friction surfacing, and it's generally down to risk and traffic levels. Interesting piece of work done by LOTAG, the London Technical Advisors Group, back in 2009. They published this interesting little diagram which clearly shows that accidents per kilometre decrease with increasing skid resistance, perhaps not surprising. You can see there the high friction features above 0.5 scrim. We're often asked how long should the treated section be? Highways England will use 50 metres of anti-skid generally. Jacobs published this interesting table a few years ago where they're trying to relate length of high friction to the actual traffic speed. It's the only publication I can find that attempts to relate the speed limit to length of treatment. And I mentioned a few minutes ago, one of the reasons why some authorities have stopped using anti-skid, or at least using far less of it, is because of this perception that you can use high PSV asphalt instead. They're very different materials. I guess the simplest way of describing it is that asphalt will polish over time, and on that basis the scrim will decrease. Providing that the anti-skid system remains in place, it should continue to deliver a consistent level of scrim over a longer period of time. And PSV doesn't equal skid resistance. It's a surrogate test really. It tries to give you some indication of what the scrim value might be. Some interesting work done by Somerset a couple of years ago where they scrimmed sites that have been treated with the SMAs from 8 different quarries, all 60 PSV, and they found that the scrim values did vary. So we know that scrim doesn't necessarily mean skid resistance. And there's some interesting research done at the University of Ulster on the same theme, using their road tester, a big beast of a machine. You've got a slab there under test under the wheel, which rotates around, and the wheel goes backwards and forwards to simulate trafficking. And after trafficking for 100,000 passes, they measure the surface friction. And you can see at the top there you've got calcined bauxite, PTV I think is pavement test value. In the middle there you've got lots of different high PSV asphalts that are demonstrating lower scrim value because they're polished up essentially. If you haven't spotted it, again there's a presentation later on this afternoon by TRL on this report, PPR 789, which compares the performance of high PSV asphalts versus anti-skid. This is based not in the laboratory, but based on real live site scrim data. I'll not burst the bubble of TRL, but it's an interesting report, and it certainly supports some of the views you're going to hear put across today.